Any questions? Physics 252, by the way, which is the same stuff that was also Physics 252 that was on here. All right, again, and I will say this probably more times than I should have to, that we will, you need to be watching the videos. What I'm doing in class is not covering everything, because there's the online component. All right, so let's go through the four basic quantities that we're working with here. Position, these are the vector quantities. And the symbols used for it, X, Y, Z, R, S. Those are the five most common ones. X is the one that I tend to use the most. And what is position?
The point where the rector is labeled as 0.
Say it again.
The point where the object is labeled as 0, 0.
With respect to, I didn't.
As in on the graph.
Yeah, okay. So, where an object is, with respect to 0 or the origin, or whatever you're considering to be sort of a starting point. Bad wording. Basically on a two-dimensional graph, it's where the axes meet, typically. Displacement.
Where an object is relative to the object starting point.
Yeah. So where an object is with respect to the starting point. And the symbol, it's also just the change in position. So if I took a graph right here, my origin right there, and I start in this position. So if you can picture that you have a map spread open, and for most maps, 0, 0 would be the coordinate 0, 0, which is, I think, somewhere off the coast of Africa. Oh, okay. We'll go with that. I got one nod, so we'll assume that it is absolutely true. So I'm starting here. That would be my initial position. And I would just write that as X with a subscript I. Now, in terms of initial position, at this point, I'm sort of settled on subscript I, but I could also potentially do a little 0 there, or an O, O for original, or O for 0. It's just basically, it's my starting point. This would be when time is 0. And so I'm starting here. So if this is, why don't we just assume that we have a map of the US. It's close enough. And I'll just put a coordinate system right smack dab right there. I'll assign that as origin, and I am starting here in what we will assume is Pennsylvania. I then move go down to Miami. So this would be my final position. So initial and final position are all based upon where I consider 0 to be. And this right here is my displacement. It is where I am relative to where I started. So this is my displacement. It is also the change in position. And so, and again, the capital delta represents change. Just a quick side note for those of you who have trouble with delta being change. I would suspect at this point, probably not many of you, but just in case, when I started doing consulting IT consulting, you either went in as part of technology, process, or change management. And each group had their own nickname. I was part of the technology, and we called ourselves the Beacon or something like that. A light shining was our emblem. But the change management group called themselves Delta Force, which I thought was a great name. So Delta for change. So the symbol that we use is just a delta in front of whatever I happen to be using up here. So this is going to be delta X or delta Y and so on. We talked last time about using I hat, J hat for determining directions. So if I said that I hat is to the right, then, and I put my origin right here, then if I'm standing over here, is my position positive, I hat, negative I hat, or zero?
Positive.
Yeah, I'm on the right side of it. Now, if it's a one-dimensional problem, which is what we're about to talk about right now, if it's a one-dimensional problem, I can get away with a slightly different shortcut. If I don't have to worry about, jumping up into the air, so I'm just gonna be moving back and forth, I could just get away with just saying to the right is positive. Or I could make to the left positive, but I can just say to the right is positive and ignore that. So for one-dimensional problems, plus and minus is sufficient. So right now, the answer you will give is going to be plus, minus, or zero. So my position,
Positive.
or positive, negative, or zero. All right. My position now,
Negative.
all right, so that's enough for position. So now I'm going to make this my official starting point. So I'm at the starting point. So my position,
Zero.
Negative.
the origin's over there.
Oh.
Yeah. Who said negative? My displacement?
Negative.
Zero.
Yeah, now's the time for zero. So I'm at the starting point. My displacement now,
Negative.
my position,
Negative.
my position,
Negative.
Negative.
it's negative. I'm still to the left of the origin. I said to the right is positive. That's how I've defined it. So I'm left of the origin. So again, my position,
Negative.
my displacement,
Positive.
yeah. And this is how the game is played. Don't worry, we're gonna make it more complicated. Velocity. Symbol for velocity is V. And what's velocity?
How fast an object is going and in what direction?
Yep, got both components to it. So how fast an object moves. And in what direction. So the sign of velocity is not dependent upon where you are. The sign of velocity is dependent upon where you are going, which way you are going at that moment. So right now my velocity is
Positive.
my velocity now.
Negative.
There was a lot less confidence in that one. My velocity is,
Negative.
all right. My velocity now,
Zero.
or is it? Are we all standing still?
Just sitting.
I got a nod yes and a shake no. What were you saying?
I said we're sitting.
Okay, so are you therefore saying that you're not moving?
Well, you asked if we were standing.
Oh, Did I? Okay. Changing that slightly. Are we moving?
No.
Okay, so that's what you were shaking. So yes, we
are moving.
are moving, and you're saying we're not moving?
Yeah.
All right, and fight. No. One of you, what's the reasoning?
We're in a constant state of motion, just whether, I mean, like, the world's moving, so we're moving with it, but also breathing, all of our cells are like constantly doing this and vibrating, as far as the molecules go, so, I mean.
You brought up cells in a physics class.
I know, I'm sorry, it's a pseudoscience.
Yeah, okay, I do appreciate that. I assume you're referring to the biology and not to the physics being the pseudoscience.
Yes.
Okay, that would be a bad way to start the semester, bad math and physics. Okay, so when you're talking about the velocity, wait, that was your argument for we are moving, and what's your argument for we're not moving?
We're sitting, so we're not really moving anywhere, so our position is, I guess you could say, zero.
So I guess it depends upon what your origin is though.
That's true.
If your origin is the sun,
Yeah, I mean, we are, I guess you could say, at rest, an object at rest, but it depends on moving as a whole.
all right, so velocity is always relative to something. Now, everyday life, usually velocity or speed is relative to the ground. We assume the ground is still, that sort of flat earth kind of, everything revolves around the earth is still, that kind of attitude. But just recognize you get pulled over by the police for doing 50 miles per hour in a 30 mile per hour speed zone. From a physics point of view, you could make an argument that you actually weren't moving at all. It was the sign that was speeding. Of course, you can make the argument that, well, relative to the sun, you're traveling way over the speed limit. So, anyway, so velocity, how fast an object moves and in what direction. Now we get to some decent math. Okay, we get to some math. There's a math definition to it. It is the change in position, or displacement, divided by time. So this brings up two things. Number one, and hopefully I remember the second one when we get there. We do need to differentiate the two types of velocity we might deal with. There is instantaneous velocity, and then there's average velocity. If delta t is incredibly tiny, we're talking about instantaneous velocity. If we're talking about, what's my average, what's my velocity? Well, let's go back to right now. I'm standing still relative to us, relative to the floor. And my average velocity for the day would be, well, it's not zero because I'm not where I started this morning. I have displacement from this morning. And so therefore my average velocity is not zero, but my instantaneous velocity is, or close enough. So if I'm asking for velocity, which one am I asking for? Well, by default, if I just say what's the velocity, I am talking instantaneous. This is my default. If I want the average velocity, I need to say average. Which also brings up displacement. If there's instantaneous displacement, it's where I have gone relative to where I just was, and then there's overall displacement. So we have that distinction. Overall versus instantaneous. And the default, if I just say what's the displacement, the default is overall. So when I'm walking back and forth, I'm not talking about my instantaneous displacement. Well, my instantaneous displacement is Okay, start in the right spot. My instantaneous displacement is negative because I was just there and now I'm here. I've moved in the negative direction. But my overall displacement is positive because there's my starting point. So if I just say what's the displacement, by default it's overall. If I want instantaneous, I need to specify instantaneous. Questions? The other thing to keep in mind here is that for these last two, there is a scalar analog. This is distance, and this is speed. And the notation, the shorthand notation looks a lot like what we have over there, just without the vector symbol. So this is delta x or delta y, delta whatever we're using, and this is just v. Probably the most common mistake students make concerning the notation here is they see v and they think velocity, but v without a vector symbol is speed. Was somebody about to ask a question? Did I cut them off? Let's just run through an example. Some of this is a repeat of the videos. So I lived in Columbia, South Carolina for a number of years. I'm in Winston-Salem, that's about 200 miles. We'll just assume that's 200 miles north. And because I really don't feel like writing a whole lot, I'm just gonna call it, I'm gonna make I hat up. So assuming Columbia, South Carolina was my starting point of my journey here, what is my displacement?
Positive.
You probably could get away with positive on that one. Let's be more specific. Given the notation I have right here, I hat. There we go. It's a vector. 200 miles, I hat. Or 200 miles north if you want. Suppose I started in Winston-Salem and moved down to Columbia, South Carolina. What would be the displacement?
200 miles to negative I.
All right, so what you said is perfectly fine. Just be careful about the way you write that. If you write 200 miles negative I hat, what that is you're taking 200 miles and you're subtracting a vector from it. This makes no mathematical sense. If you want to put the negative afterwards, which is traditionally not done, but if you want to put it afterwards, you need to put that in parentheses. However, it is also acceptable to put the minus sign in front, and this is the way it's traditionally done. Negative 200 miles I hat would be going 200 miles, opposite of I hat, which is down. So the negative in front is a reference to the direction, even though it's separated from it. Now, questions to there before I add to this? So I'm starting in Columbia, South Carolina, starting here, coming up to Winston-Salem, and I decide to take the scenic route. Go over to Oklahoma, visit the world's largest prairie dog, maybe Arizona to see the thing, and end up back here, and on the car, it says I have traveled 2,000 miles. What is my displacement? I think I heard it correctly. Kelly, yours was the clearest voice.
200 miles, positive I had.
Yeah. You don't have to say the positive. The positive's understood, but there's nothing wrong with it. All right, what's the distance I traveled? All right. So if I got from here to here, taking the long tortured route, 2,000 miles is probably way on the low side there. My average velocity. Let's see. Would be my displacement over time. And so let's say it took me a month. Let's say it took 30 days to do this trip. What is my average velocity? Let's make it an easier number to work with. Let's make it 50. So if it took me 50 days to do it, what is my average velocity?
40.
Give me the whole thing.
40 velocity. V average equals 40 miles a day. A month.
All right, let's take a look at that. Anyone want to just chime in before I spoil it?
miles a day.
You left off the thing that is frustrating from a grading point of view. You're thinking, oh, you're losing points. You're losing 3 out of 10 points just because you forgot something. Did you say it and I missed it?
We average 200 miles over 30 days.
All right, so there's the math. So what is my displacement again?
200 miles.
I had
Oh.
divided by 50 days.
Up at the end.
I changed it. Let's make it so it actually looks somewhat legitimate. So we end up with 40 miles a day, per day, I had. What's my average speed?
40 miles a day.
No. Doesn't quite